So, good evening, everyone. Let me start the session for today. We are in the 12th week of this problem solving session for the NPTEL course, Wastewater Treatment and Recycling. So, I welcome you all for the last lecture. And those who joined new today, I'll introduce myself. I am Saravanan, Prime Minister Research Fellow and PhD scholar at NIT Tiruchirappalli, Department of Civil Engineering. And this is my fourth uh, course in the NPTEL. First, I have taken solid waste management by Ajay Kalamdat sir, and plastic waste management by Brajesh Kumar Dubey sir, and then mm, I have also taken air pollution and control, and this semester I am taking wastewater treatment and recycling. So my session will be on every Monday 6 to 8 p.m. The first 1 hour we are going to discuss the same lecture material what Sir has discussed in the YouTube lectures, and then another 1 hour we are going to see the old assignment problems. So all the lecture material credits goes to Dr. Manesh Kumar Tiwari sir from IIT Kanpur, and let me start today's session. So first 11 week we have discussed about what is wastewater and why we need to treat the wastewater, right? So the concept behind wastewater and treatment and recycling that we have discussed in the first week. In the second week, we have discussed to manage the wastewater, we need to know how much it is generating. So the quantity matters. So based on the population and the design life, we can easily to calculate the quantity of wastewater going to be generated in the future. You got it. So in the second week, we have quantified the wastewater generation, and in the third week, we have discussed the quality of the wastewater. That is BOD, COD, DO, solids, nutrients, and physiochemical and biological parameters of wastewater we have discussed in the second week and third week. And then natural attenuation of the pollutants in the river. So a river has its self purification process, so we have discussed the different zones in the river for self purification. We are disposing the treated or untreated wastewater in the natural water bodies. Okay, and then fourth week we have discussed about the treatment philosophy. So before starting the treatment, we need to know what are the concept or the mechanism behind the treatment process. So in that we have discussed about the different reactor types. So because all the treatment system we are doing in a reactors, any rectangular or cylindrical or circular reactors with design flow, design volume, HRT, that is the hydraulic retention time, and then the in inlet and outlet concentration. Based on that, we are designing the reactors, right? So based on that, we have classified the reactor into batch reactor, plug flow reactor, continuously stirred tank reactors. We have discussed the mechanism and the mass balance concept as well as the kinetics. In the fifth week, we have started with the treatment process. First is preliminary and primary. There we have discussed about the screening process, equalization, utilization tank, primary segmentation tank, grid removal, and all we have discussed. In the sixth week, we have discussed about the secondary treatment system, that is mostly biological. We have mostly relied on the advanced oxidation, advanced activated sludge process, ASP. In that aeration tank will be there, and followed by a secondary settling tank. There we have also discussed the aerobic as well as the anaerobic process of wastewater treatment. In the seventh week, we have discussed about the anaerobic process, that is the UASB, that is a upflow anaerobic sludge blanket reactors, fluid as a bed reactors, and then biogas protection and collection systems and all we have discussed. In the eighth week, based on all this treatment system, we are producing some sludge, right? In screening, we are getting sludge. In the primary setting tank, we are getting a sludge. In the grid chamber, we are getting mostly the solids, inert solids, and the secondary setting tank, we are getting the biosolids. What we are going to do with all this sludge? So sludge management we have discussed. In that, sludge conditioning, sludge thickening, sludge drying, sludge dewatering, finally sludge uh, disposal that we have discussed, right? And the ninth week we have discussed about the tertiary treatment. In that, mostly we have discussed on nutrient removal, dissolved solids removal, like membrane process, ion exchange process for the removal of salt, and nutrient like nitrogen and phosphorus removal, both by biological as well as the chemical systems. In the 10th week we have discussed the current treatment approaches in the field. Now we have moved from ASP to new technologies like SBR, MBBR, SBBR, and MBR. So that four treatment system we have discussed and this case studies. Last week in the 11th week we have discussed on wastewater recycling, mostly on theoretical part. So to recycle the wastewater, it's have different types like portable reuse, non-portable reuse. How can we design like centralized system or decentralized system? What are the advantage? Where we can choose which system and all we have discussed in the last week. Finally, this week we are going to see the 12th week concept is challenges, risk, and research trends on wastewater recycling, mostly on recycling or reuse. So, how the people are accepting the recycled water? How can they reuse? Can we able to make them reuse, or what are the factors and difficulties, challenges in the wastewater reuse on the public perception and all we are going to discuss today. Okay, and also the risk and associated challenges. How other countries are pioneer of this recycling and reuse options and different failures they have learned from the failures that and all we are going to discuss today. You got it? So today it's on challenges, risk and research trends on wastewater reuse and recycle. Let's move on to the lecture. See, before going into this, we need to know the problem analysis approach. So, for wastewater treatment technologies, it can be a design consideration, that is a technical design, how we are going to treat, how much cost it's going to involve, system analysis, like the impact on the surface water, groundwater, and it's on the soil, and the consumer side, that's the public perception, how it's called industry, commercial, where they are going to reuse the water. So, these are the four major sectors on the wastewater recycling and reuse. First, how we are going to treat, how much cost it's going to use for that, who is going to use the treated water, what are the impact or risk it's going to cause on the environment and human health. These are all the whole boundary for this impact assessment. That's the problem analyzing approach. Then what are the challenges we are going to see in the technical side as well as on the all this impact side. So the increasing quantity of the reclaimed water use have challenges like there is a treatment technology, a good treatment technology is available. We are getting, because one day if we are generating 100 liter per capita, then surely we are getting at least 70 to 80% or 90% reclaimed water. So at least 80 liter we will get. So huge quantity we are reclaiming, but the reuse challenges we need to address, right? First is compliancy. It's matching with the quality standards or not. That's the reclaimed water compliance with the regulatory standards. That's the first point. Am I going to treat am I treated the water to the regulatory standards or not? That's the major question people will first ask. Then the technical compliances. High degree of treatment is required or not for all the purposes. I'm going to reuse the treated water for toilet flushing. Do I need to remove all the solids and all the impurities in that water? No. For the particular reuse, I can treat to that much level only. So that high degree of technical competence, again, it will incur high cost, right? So the cost is second, third part. Then the system reliability. Can I rely on the system whether it's working good? I am changing from ASP to SBR as BBR or MBR. Whether it will give the exact result to the like the conventional treatment, or it's giving the more result or less result. That reliability matters. Then the risk reduction, there is a challenge like social acceptance first. Health, public health, we need to take care, because public perception, that's a major stigma on the recycled water reuse. And then trade barrier. Some countries will not import if India is using wastewater in the agricultural field, the treated wastewater in the agricultural field for irrigation. Then some other country will object for the import of fruits or vegetables or the crops from the reusing country. So it's a major trade barrier for the country, right? So that stigma we need to remove by showing the proper monitoring and like the reports and all we have to show, like the treatment compliances with the guidelines. Based on that, the crops, how much accumulation is there, bacterial accumulation, heavy metal accumulation, impurities accumulation and all, I have to test and I have to show the report to make it understand. Then political constraints, lack of political motivation in the wastewater recycling and reuse. That's another major challenge. See, research trends nowadays we are having in wastewater reclamation and reuse. We have a good technology for intensive resource focus already happened on the wastewater effluent treatment to a maximum standard of even for drinking we are using, and for industrial application. For drinking, it will be called as potable, because potable means people are going to consume it. So for potable reuse, such as drinking water also we can use, or indirect potable reuse. The indirect potable reuse means, as we discussed in the last section, the treated water, let me take the pen, the treated water will be injected into the groundwater, or it will be discharged in the surface water bodies. After some time, I can take it, I can use it, treat it in the water treatment plant along with the water source, and then it will be going to the consumers. So it's again going to be a potable reuse, but indirect. If it is directly treated water I am supplying to the consumer for drinking purpose or any other potable purpose, then it is direct potable reuse. Then fit for purpose, that is the major research trend. Should I need to treat the wastewater to a drinking water quality standards for toilet flushing? It's not required, right? So based on the purpose of reuse, I have to treat. That's what we are going to discuss in the next slide also. So cost effective treatment extends need for fit for purpose for water reuse, because drinking water quality treatment requires high cost, but I don't want to use that for drinking purpose, so I can reduce or optimize the cost accordingly. Then integrated urban water management, like alternate source I can think upon, like stormwater, rainwater, and all will be mixed with this treated wastewater for the reuse purpose. That type of integrated urban water management also research trends are going on. Then energy production and conservation. Can I use this biosolids for energy production? Can I use the treated wastewater for the energy production? That kind of energy production as well as for conservation. Because if I am using the treated water for potable reuse, then am I reducing the cost and energy incurred in the treatment of fresh water and like sourcing of the fresh water? This and all, I am reducing the cost as well as the energy incurred in it. So this kind of energy conservation plays a major role. That's what called water energy nexus. This is a major research nowadays going on. People, those who are in research side, they can think about water energy nexus to develop and establish more energy efficient technology for wastewater treatment. I can choose between the treatment options. One may be SBR, one may be MBBR, one may be ASP, but which is energy efficient for my application. So this kind of energy efficient technology I have to choose. That's called water energy nexus. Then nutrient management. I am getting lots of nutrients like nitrogen, phosphorus, potassium from the wastewater. Can I extract the nutrient and reuse in agricultural field or any other nutrient applications? That kind of thing. Nowadays in Chennai, even last like 2010 itself, they have started in Marina Beach. They have a separate urine tract collection. Without water, it will be going to nutrient recovery, because our human urines contains lots of salt that can be recovered. This type of nutrients recovery process are nowadays research trends are blooming. Okay, so that type of nutrient recovery and management in the recovered water, it should be within the effluent standards. That and all need to be taken care. And then residues and biosolids management, as I mentioned, it's a major burden. As I mentioned, like in the seventh week, how much quantity of solids are coming with this wastewater, that where we are going to dispose, like composting up. Again, we need to do anaerobic digestion. This and all we need to think on this burden, and it should be again thought of a source of potential revenue after reclamation. We should not think biosolids as a burden. We can also think a revenue generation option for this biosolids. And industrial wastewater purposes, like for industries, they can think about ZLDs, like biological industrial treatment process, ZLD option. India mandates ZLD in all the industries, regulatory impacts, etc. These are all industrial wastewater purposes. Research are going on. And innovative technology development. After this MBR, MBBR, we can also think about AOP and advancement in AOP, the cost-effective catalyst or any other energy efficient treatment option in the membrane itself. We can think on that will be a cutting edge technology for the solids recovery as well as for like effluent standards. Then wastewater utility management, where we are going to utilize the troubleshooting by meeting with the regulatory criterions, public outreach. That research is going on in the humanity side, like social acceptance side, and instrumentation controlled automation. Some treated waters need to be sent along with the water treatment plant that need to be automized. So that automation in the wastewater system is required. Then cost reduction. Finally, based on energy reduction conservation, the cost reduction plays a major role in. If you think on membrane filters, advanced oxidation process, we are thinking about less cost catalysts. So that is to make it more affordable. That is a recent research trends. Then, if you are coming to the decision making, which still we are looking on which system is best for my treatment plant. As last week also, some students have asked the question, which treatment plant I can adopt for my apartment. So that decision making, and also after treatment where I am going to use that decision making is will also based on the impact assessment we are going to see in this lecture now. So see the way like the complexity of the wastewater management plan. Recycling is the major complex and dynamic in nature, because we can't recover water as a homogeneous or static way. It will be dynamic. It's varying with the time. So that need to be taken care, and ensuring its safety and reliable reuse plays a major role. The factors affecting this recycling will be water quality, technology, fund, that is a cost, and then regulatory requirement, operational constraint, public perception, and environmental concern. We are going to see one by one. First is the treatment technology. We have a different treatment technology from biological to membrane, physiochemical, and all. Biological, we have a low rate and high rate system. That is with the flow rate we are talking about. Low rate will be usually natural systems like constructed wetlands, ponds, UASBs, and all. High rate system will be biofilm based like ASP, trickling filter, RBC, and all. Membrane system, as we know, nano, ultra, reverse osmosis, and MBR systems. That is again a biological but high rate. Then treatment philosophy, if you know how much degree of treatment we are going to do, treat only on the desired degree. That is the major rule, fit for purpose rule. Treat only to the desired degree. So some standalone technology will be there. Like I can't use AOP for wastewater treatment, and then the treated water will be going for toilet flushing. That is waste of money. So combination of unit must be required. Technical feasibility, financial viability, environmental sustainability, social acceptance. These four are the pillars of wastewater reuse and recycling. As I mentioned, fit for purpose reuse, wastewater treatment. Like reuse application, I need to know. Based on that, I can grade the water quality, number of treatment levels required. Can I stop it at the primary treatment? Can I stop it at secondary treatment, or I need to go up to tertiary treatment? So that and all I can decide. The decision making plays a major role. So in the production of high quality water, it's over treatment. Or if you are reducing the quality of the water, then again it is unnecessary for reuse. So that optimization plays a major role. So unnecessary cost and energy we should not give, and less treatment also we should not give. So we have to give a optimized treatment so that it can meet my reuse purpose, right? That is called a fit for purpose wastewater treatment. Avoid over treatment, obviously no under treatment. That decision you please make on. So then how to make the decision making, like there is an array of treatment technology which I will choose based on the alternative technologies available. We can decide based on two factors. One is the cost, other one is performance level. So this optimization can be done with the proper overall flow chart I will discuss now. That is a suitable mechanism that is called decision. Let me discuss the chart now. Decision support system framework. In this decision support system framework, we are having n number of treatment technology. So in that, among the treatment technology, how much health risk it's going to cause, how much carbon emission it will give during the process, how much energy it will use, how much water I can reclaim, how much the life cycle cost. Life cycle cost in the sense from inlet to outlet point, or until the end of life of the treatment technology, how much cost it will give. That is the life cycle cost assessment. All this factor will be analyzed with the multi-criteria decision. This is called a multi-criteria decision analysis. It will be fed into the fuzzy logic weighing and aggregation method. Finally, we will get a score. So with this score, I can decide which treatment technology is having high score. That high score is not good for. Uh, I mean, if it is the score is based on the impact, high score is not suitable. Less impact I can choose. That decision making is based on DSS, decision support system. Let me mute. Sir, can you mute yourself? Uh, Purnana sir, I think you are unmuted. I'm muting you. Okay, let me continue. So this is called a decision support systems framework. So among the alternative technologies available for the treatment of water and recycling, I have to know carbon emission, energy cost, cost incurred in the project, life cycle cost, and health risk. Based on all this, it's called a multi-criteria decision analysis. I can feed it into the first based system, and final score I can get. Based on the final score, I can decide the system. That's called decision supply system. So see here, there is a trend on reclaim the water. High importance is given to the devise a mechanism. We still don't have a mechanism or a decision for a particular treatment technology. So it's based on the case study. Case by case, it will vary. Okay. However, one which is suitable for a country which is not suitable for other places, like other countries are using membrane technology, like Singapore is using desalination from the like ocean water, marine water into drinking water. I can't use the same in India. Like even though it's having three side of oceans, I can't use that in a central part of India. So I have to decide a technology for reuse based on the local conditions. So we need to customize the solution according to the local need, right? That is called decision making. So development of a decision support system is mandatory to support in choosing a consistent optimum solution. Optimum in the sense both energy and the cost optimization. So this works based on selection and design of treatment process. Which one I can decide? Sequence. So first I can give this ASP, second I can give a nutrient removal, third I can give AOP, fourth I can give reverse osmosis. So this kind of sequencing is based on the selection and decision making. Then monitoring and control, because the system need to be monitored properly. Finally, identifying the reuse purpose for the treated effluent. This four will come in the decision system. See the four one. First, we need to list the possible alternatives, evaluate among the alternatives, and then choose the correct option based on cost, energy, removal efficiency, land impact. Finally, assessment of possible impact of implementation of the scheme. This is the four pathway in decision support system. So see, example of decision support system in air treatment plant. They have chosen ASP, extended aeration, lagoons, trickling filter, and biodisc or RBC, and they have assessed different factors like volume, age, BOD, suspended solids, and phosphorus, and the energy intensive systems. So for a trickling filter, the energy is required mostly on the volume part, because to feed itself it requires lots of energy. In biodisc, volume and phosphorus removal takes much energy, but in aerated lagoon, all the energy is invested only on BOD removal. In extended aeration, some part will be for age and some part will be for volume. In conventional ASP, all nutrient BOD removal, volume and age of the sludge plays a major role in energy utilization. So based on this contribution of energy, this analysis will give you a broad idea on which system can I choose for removal of any particular parameters, right? So this is the framework for decision support system. Finally, the main problem with this recycled water use is public acceptance. See, there are a lot of challenges from regulation, rules, finance part, that is the cost is the major part, then stakeholder collaboration, customer engagement, policy, but the the important one is the public perception. It will be inform or influence form. So public perception plays a critical barrier to the implementation of recycled water schemes, because if I am not using, I am not allowing my community to use, means where can I put the recycled water? That is the problem here. So this is a major consideration for recycled water schemes. How can I, is it a technology challenge or is it a public perception point? Economic, technical, and environmental feasibility is secondary, but first is public perception. If it fails before, during, or after their execution, like irrespective of scientific evidence, public opposition can cause this project will fail. So if I am going with a project, if the public is not accepting, even though my economic cost is there, even though the technology is good, even though it's not causing any impact on the environment, but still, if public is not accepting, the project will fail. You got it? So extreme volatile on issue, like it will cause a concerns on some population group. It will lead to the complete rejection. That's why nowadays the environmental impact assessment rule notification, latest notification mandate, public meetings before implementing any project like construction project or any project that causes impact on the environment need to be the public hearing need to be there before implementation of the project. So that is the final stage. After completing all the assessment, we need to have a public hearing. If any one population opposes, it's a complete rejection of the scheme, or any amendment need to be done to implement the project. So importance of public acceptance is, see, the wastewater project have been abolished if the community is thinking this as a X factor in the sense they are not ready to use this. In developed, even in the developed countries like USA and Australia, people are still not accepting the recycled water for usage. Like they are preferring harvested rainwater instead of recycled wastewater, because I still have a stigma. Recycled wastewater have pathogens. Recycled wastewater have like impurities. So depend on the individuals and the community perception. Like we have different factors like age, gender, education, income, awareness. So most of the people oppose the use of wastewater. Less opposition will be given to use of water in irrigation, instead of directly they are supplying to the community. So if I am supplying to a community for washing or drinking or for bathing, they are not accepting. But if I am supplying for agricultural field, they are accepting. So most less opposition is going to be irrigation purpose. See, the factors, socio-democratic factors, age-wise, younger people are ready to accept than the old age people. This is normal because educated people. Then gender, men are more accepting than the women because they know the constraints. So that's the problem. Then education, people with a higher level of education have higher level of acceptance. So that again based on the age. Okay, then income. High income people associated with the higher level of acceptance. And the religion, people have non-religious, they are accepting because some religion, they have the criteria of not using the wastewater. So that and all affects the reuse purpose. So that need to be taken as a socio-democratic factor. Then psychological factor, disgust. If the people are thinking that as a X factor, then it will be disgusting to the significant number of people. Then health risk, the human health matters before instead of environment, human health first. Then that need to be taken care. Then trust in the authority to manage the risk. If anything happens, or even though if it is pure, if anything happens, the trust need to be there with the authority to take care. Then the fairness, it should be given to all the community, not only to the low community. It should be given to supplied to all the people. It is not only the wastewater is supplied to this region, another region is supplied with the fresh water. That is not that should not happen. So the fairness of supply makes the target users to cooperate. Then belief in the science and technology. So people need to believe this technology that it is treating the water well. Then the environmental consent, that is the final thing. Issue, it should not create any issue to the impact on the environment. Okay. Then the psychological factor, that is one of the survey in Bangalore. It shows people are see, the dark color is very concerned. Less like light red is fairly concerned. So see, lack of trust on agency. I can afford to buy. So people are having more concern on water availability and accessibility. So can I access the water, or psychological awareness? It's a X factor. They are considering the more concern they are giving to this kind of factors. Similarly, if you have some more examples as survey results shows, let me finish this. So the management operational factors such as knowledge and information, wastewater source, where it is coming from. That's the, if it is a gray water, people are ready to accept it. If it is not a gray water, like yellow water or the black water, people are not ready to accept. Then treatment option. they are ready to, they are okay with recharging aquifers instead of direct potable reuse. If I am giving for drinking water, they are not using, but they are discharging in the uh, groundwater, then again taking it and treated in the wastewater treatment plant, they are accepting. And water pricing, people are more willing to accept recycled water if the water bill is very low. Or if they come to know, I am using wastewater, so I have no need to pay the water bill, then they will usually accept this. Okay, then stakeholders participation, involvement of all the stakeholders like educators, researchers, public, government, industries need to be in a single hand to tackle this issue. Then success and failure stories, that will increase and decrease the public acceptance. Then quality of treated water, negative aesthetic attributes related, that will have a lower acceptance. Then type of use, as I mentioned, they are ready to give for irrigating non-food crops, recharging groundwaters. But high level of acceptance will be given this kind of thing instead of potable reuse. Potable water use has the lowest acceptance. Then regulatory norms, motivation and reward. If the government is giving reward when the people are using the wastewater, the treated wastewater, then the people will ready to accept. See the willingness to use the recycled water in Iran. Iran is one of the pioneer in wastewater reuse and recycling. So see, uh, dark color is disagree, shade is agree. So public use, they are agreeing. 87% people are agreeing. For car wash, 85 people are agreeing. Flushing toilet, 80% of the people are accepting. But for taking bath, 50 people are opposing. For cooking and drinking, 80% of the people are opposing. See, the black color is dominated here. In even for washing clothes, people are, for half of the people are disagreeing. See, so willingness of the people to use for different purposes, agricultural irrigation, most of the people are accepting. See, that's the case study. In Israel also, if you see the case study, for public parking, firefighting, people are accepting, like 90%, 99% are accepting. But for fishing and boating, the people are not accepting. Like if it is a portable kind, air conditioner also, car washing also, people are accepting. But for direct portable use, people are not accepting. Similarly, in California, if you see, water lawning and flushing toilet, people are accepting. But for drinking, cooking, and bathing, only 20% people are accepting. So how to enhance this public acceptance? How can I talk to the person to make it first is regulatory requirement. I can say it is an irrigated water. It contains this much only the contaminants. That's regulatory standards. Rewards and subsidence. Public awareness campaigns. Government need to create awareness among the public. Knowledge on water cycle. If the people are educated, they will know. Like it's all our water cycle only. Like inclusion of media and women control, because women are having less acceptance, men are accepting a lot. So media and women, if they are included in any project, that will become successful. Then control on groundwater abstraction, if the people, if the people are relying on only the groundwater as a source, if I cut the source, they will come for the alternate source like recycled water. So control on groundwater abstraction is a major role. Then technology advancement in demonstrating projects, we have to have a conclave or demo or exhibitions to showcase wastewater will be good. Success stories like Singapore New Water success story, we are going to discuss in detail about New Water. United States, they have success stories, but failure stories again there is San Diego and Los Angeles failure stories even in Australia. See how the wastewater reuse program around the world happened. Adopting urban water reuse for various applications like irrigation to industrial use, people are using like demands in arid and semi-arid region. If the water is not there, people will think on wastewater reuse. So semi-arid and arid region, people are looking on alternate water supply sources. If I have huge groundwater potential, why I will think on wastewater, treated wastewater? That's the problem. Then practice in Singapore, you see, Public Utility Board (PUB). They introduced a membrane technology. So the public is generating wastewater and the industry is generating wastewater that is collected. Water reclamation plant treated water. They will do the membrane treatment, and that is called new water. Even the name, see the name, instead of wastewater, they are saying new water. So the terminology matters. With this name itself, people are accepting. So the new water is mixed with the groundwater blended with raw water and then going to the water treatment plant, and the people are drinking it. Even drinking they are doing, because membrane treatment, it will remove all the impurities in the water. So that is a good option. So new water blooming. See, new water users, they can use for non-potable and indirect potable use. Non-potable is for any wafer fabrication. Like new water biggest user is the wafer fabrication plant and the air conditioning industrial reuse they are using. But indirect potable reuse is first they are blended with the raw water. That raw water can be treated in the waterworks and it is applied to the consumers as tap water, right? So Singapore is pioneer in wastewater treatment and recycling even for potable applications. So critical success factors are they have a strong support from the government. That is the first thing. And then reference project, technology demonstration into the local environment. People are doing this kind of new visitor centers. They can come and see anytime. And then the rigorous assessment of the water safety, auditing, proper monitoring need to be there. Once I have done the technology, I need to monitor the technology periodically and I need to showcase to the public it's working good. Then endorsement by a panel of expert every like periodically they are reviewing the uh, progress. And then effective public and customer engagement. Public engagement matters. Then engaging the media. We have to show public what we say, like through advertisement we have to make the people aware of this kind of technologies. Community engagement. Then the name itself matters. New water instead of wastewater, treated wastewater, they are saying new water. Then think about the case in California. They have a success story of groundwater replenishing system. So the treated water they are sending to the groundwater for replenishing. Then from the groundwater, after some time, it will get self-purified and it will be taken for again potable reuse. So before recharging the groundwater, they are doing microfiltration, reverse osmosis, and UV light. So all the tertiary kind of treatment they are doing before discharge. So that kind of advanced technology need to be there. Even simple ASP I can do and then supply is wrong method for portable reuse. So they have a target of 70 mgd of highly purified water in 2008, then that got increased to 130 mgd in 2023. Same success story like Green Acres project, like OCWD is the Orange Country Water District, California. They are using the water for irrigation at the parks, schools, golf courses, and industrial reuse. Another success story is Florida. They are using the water for residential yard, golf courses, park and ground, agricultural land for edible crops, not for non-edible crops. For even eatable crops, they are using wastewater, treated wastewater for agricultural irrigation. See, irrigation they are doing 25%, agricultural irrigation 10%, totally 35% they are using for irrigation alone. Then groundwater recharge 14%, industry 18%, so golf course and other public places they are using totally 20%. So see 25%. That the success story. So they are treating to that much level to apply for edible crops also. Practice in Israel, people are 85% of the Israel wastewater is treated, reused. So think about India, 76% are not treated and disposed based on the last week's class. But they are doing 85% wastewater purified and they are using for agricultural irrigation. Roughly 10% is used for environmental purpose. 5% is discharged into the sea. So that is treated 5% water is discharging into the sea. In Japan, they are doing for urban applications like road washing, cleaning road and snow melting, that kind of thing they are using. They are having a vision, sewerage 2100 vision, suggesting creating sound water cycle by using reclaimed wastewater effectively. See how they are doing the water, the wastewater that is collected, that is treated, the reclaimed water will be supplied to the different part again. That's the water cycle. Still, this system is there in Japan, in Tokyo also. See, Tokyo Metropolitan Government, they are using the wastewater for toilet flushing in a wider range, and these are all success stories. In Australia, there different states are having high volume of recycled water. Like Victoria, they are having 24% of water that is recycled to the community. See, even 25% itself a good number for 20 nowadays in 2025. And major use is agricultural augmentation groundwater supply. Australia, they are doing mostly agriculture and groundwater supplies. See, all the states are having good number of more than 20 of recycling. The pumping recycled sewage back into the city, it's a major problem. So again we need a proper energy and pumping station. Instead of taking water, we are taking the like my city is here. I am generating wastewater that need to be transported to a long distance for treatment, STP. Then again the treated water need to come to the city for reuse, right? So that is taking a large time and energy intensive process. So that's why we are last week we are discussing about the decentralized treatment plant. Inside the city, different communities having different wastewater treatment plant. They have to treat and reuse in their community itself. Then Europe and UK, they have a practice of microfiltration and reverse osmosis, and then water supply augmentation. Again, they are recharging the underground aquifers. Okay, then in England, in Millennium Dome, they have a Thames River, so they are discharging into the river, blended with the groundwater and fed to the reed bed. That is to the construction wetland also, they are supplying the treated water. Flushing toilets and urinals. And Germany and Holland, they have a toilet flushing and laundry, car washing reuse. Italy, Poland, and Hungary, they are using even for irrigation purpose. Other nations, 4 sewage treatment plants are there in like they are using for cleaning and wiping, also for plants and the roads outside the plant. That is there for industries. Then African countries are using for augmenting potable water supplies. Since they are arid and semi-arid regions, they are relying on this type of treated wastewater for potable use. And other countries like African countries, they are using for irrigation in agriculture. Jordan and Kuwait, they are using 80% of the treated wastewater in discharge into the Zergra River. So see the quality of water to be used, to be discharged into the river, so that it can be blended with the fresh water. You got it. But in India, if you see the practice, Chandigarh, we have a the treated sewage is used for horticulture. And Indian Agriculture Research Institute in Cornell recommended irrigation method for sewage fed tree plants. We still have a guidelines, because if small pathogen are there, last week we have discussed less than 1 or nil it should be the helminthics and pathogens, so that it can be used for irrigating edible crops. Otherwise, it's not acceptable. So Indian Agriculture Research Institute have a recommended code on this. And Bangalore is the first city to recycle sewage for augmenting domestic water supplies. A pilot scale model similar to the Singapore New Water was developed. And in India, if you see Gandhi International Airport in Delhi, Indira Gandhi International Airport in Delhi, they are doing this type of reclaimed water for cooling towers, toilet flushing, and horticulture. In metro cities like Delhi, Mumbai, Chennai, and Bangalore, they are using for toilet flushing in high-rise apartment buildings, and they have a designated institutional centers for recycling water. Different examples you see, like Vasavi thermal power plant, like sewage reuse scheme at CPCL in Chennai, Chennai Petroleum Corporation, and Rashtriya Chemicals and Fertilizers. Is, some of the examples they have given how they are reusing, or first how the treatment is happening, and then how they are reusing. If it is a microfiltration, RO or UV or AOP, we can even use for potable reuses. Okay, then in industry wastewater, if you see, CPCB in Government of India mandated zero liquid discharge policy, ensuring complete recycling of industrial effluents. So it's mandating the gross polluting industries. What are gross polluting industries? Industries generating more than 1 lakh of wastewater every day, 1 lakh liter. So that kind of industries are called gross polluting industries, like thermal power plants, steel industries, petrochemical industries, chemical and pharma industries. These industries are mostly water intensive industries. So they have a pilot project on groundwater recharge, and detailed risk assessment and mitigation along with the proper planning and awareness is given. See, water use and the future. We have to think on. See, these are all some of the utility plans. The city is generating the wastewater that is going to the wastewater treatment plant. The effluent can be discharged into the river. Again, it will be indirectly taken for water treatment and supplying to the city. That is called indirect potable reuse. Or we can recharge the groundwater. We can send it to the industry for some other purpose, or we can send it to the wetlands, or we can send it to the agricultural field. You got it. So see the direct industrial use is 3. Sorry, not 3, 1. Flow augmentation 2 is like wetland flow augmentation. 3 is direct agricultural use. Fourth is groundwater recharge. Fifth is again we are supplying to the city as a portable urban reuse for toilet flushing and all, not for portable. It's like a non-contact reuse. Sixth is indirect portable reuse. Seventh, is there any seven? Yeah, that is also indirect portable reuse. Eighth is indirect agricultural reuse. You got it? Read this to know how can we plan. So we can also use about the energy factory, nutrient factory, water factory to recover first energy, then nutrient, then water. Finally, the remaining part we can discharge, or treated part we can discharge. So we have a lots of water recycling code given by the different agencies like IWM. They have a thing, and US EPA they have a thing, and UNESCO they have a guideline, as well as um, IWA they have a code, EPA they have a code. I will upload all these documents in the reading material. You can look into. So that's all about the whole reuse option and what are the challenges, issues, and the public perception, acceptance, and decision making in the wastewater treatment and reuse. Hope you got a clear idea on this. If you have any doubt, please post it in the chat box, or you can unmute and you can ask. Otherwise, I will move on with the problem solving session. Today is mostly theory, so it will be very easy on the problems. Okay. So if you don't have any question, let me move on to the problem solving session. Yeah. Can I please post the answer in the chat box? I'll read the question. So the first question is, identify the correct statement regarding the challenges in wastewater recycling. So the first statement is, identify the correct statement they are asking. Although efficient technology for wastewater treatments are available, using recycled water is relatively more complicated than using conventional wastewater. Is it correct? Although it is available in a huge quantity, its usage is complicated than using conventional freshwater source. So if you are provided with a cup of fresh water and if you are given with a cup of treated water, which will we choose? So there is a complication even with the public perception itself. So it's correct. Second statement is, further, cost of using conventional water is often less than the cost of using recycled water. Is it correct? Which cost is higher? Conventional. Let me take the pen. Using conventional water is costlier, or using recycled water is costlier? First statement is correct. Second statement, cost of using conventional water is often lesser than cost of using recycled water. I think recycled water cost is higher because recycling will take lots of energy and cost. I think first statement is correct, second statement is incorrect. No, both are correct. Let me see. Water recycling typically has higher cost than using conventional water. So, I think correct. First statement is correct, second is incorrect. Because, as I mentioned, see, reclaimed water use is complicated than conventional. Water recycling is higher cost than conventional. So, uh, both are correct. Sorry, first is correct, second is wrong. Because further cost of using conventional water is less than. Okay. They are saying conventional water is less than. Okay. Okay. It's less. They are saying less. Okay. Which is costlier? Recycled water is costlier. Which is more complicated? Using recycled water is complicated. So we need to change this trend. Then only we can succeed in wastewater recycling and reuse. Okay. Now please read the question carefully. Okay. Second one. The approach that considers alternate resource including wastewater, stormwater, and rainwater. What is this called? There is a lot of research are going on. One type of research is using a combination of wastewater, stormwater, and rainwater. What is this called? Successing for design urban water services is popularly known as integrated urban water management, because in urban water management itself we have stormwater, we have a separate rainwater harvesting system, we have a separate treated water. So how can I integrate all this into the public utility purpose? That's called integrated urban water management. So there is a research going on this. See, so richest strengths of research are in integrated urban water management to integrate alternate resources like wastewater, treated wastewater, stormwater, and rainwater, and usual surface and groundwater resources. So I have to merge everything. As then only I can utilize less on the natural resources. Okay. Then coming to the decision support system (DSS) for wastewater management, which will help in choosing wastewater treatment process based on cost, energy. It's correct. It's useful for choosing. Identifying most appropriate treatment alternative for specified recycling reuse option. That is also correct. Based on the reuse option, it will choose the optimum or most appropriate treatment technology. Assessment of possible impact of implementation of the scheme. That is also correct. Final stage is implementation, how much impact it will give. That impact assessment is the final stage. So all the above is all are correct. So DSS is the major tool used for the decision making, decision support system. Let me check that. Okay. See the answer. It will help in choosing the appropriate alternative. It will help in assessment of possible impact during the implementation of the scheme. Okay. Okay. Fourth one. Among the given sources, which of this typically have the higher public acceptance for municipal uses? Which will people will think on treated industrial effluent or treated sewage or harvested rainwater or treated black water. Public have more acceptance towards for municipal use. So if I am a public, I will choose from rainwater only because that is pure. I will think. So harvested rainwater post treatment, I will have more acceptance. See, public have acceptance on wastewater reuse depends on individual. People prefer harvested rainwater over recycled wastewater. If anything may be from industry or from municipal or from grey water, harvested rainwater is good. That's what people's perception. Which of the following is not considered as water energy nexus? What is water energy nexus? They will consider which option is having less water intensive, less energy intensive, less cost. That water energy nexus or which system, treatment system are having treatment technology having less energy. This is water treatment technology only. Which water treatment technology is having less energy consumption or energy footprint is called the water energy nexus. So which will be considered for that energy required for water supply, I will take. Water quality required for hydropower, quality not matters. Energy requirement matters. Water required for energy production, I will consider. Energy production from wastewater management, I will consider. So, water energy intensive water process or after reuse, what can I use that water for energy production? That and all will be considered in the water energy nexus, not the water quality. It's based on the quantity and the pressure. See, so the answer is water quality is not considered for water energy nexus. So water energy nexus develop and establish more energy efficient treatment technology and alternative energy production methods for wastewater and sludge processing. That's the major point. So from the sludge, I can use to produce biogas. I can burn to produce energy. So that and all plays a major role in water energy nexus. Okay. So match this wastewater reuse application and level of willingness. So people will think more on high willingness is for irrigation or car cleaning. I think people will think more on irrigation. Low willingness is for drinking. Medium willingness for house cleaning and car washing. Is it correct? BAC. First one is correct. Okay, because I don't want to drink the treated water, so it will be less acceptance. But for house cleaning and car washing, it is again contact reuse, so medium. But irrigating lawn and garden, it will be somewhere no contact. So I will use the wastewater for that, treated wastewater for that. So I have more willingness to use that. See, cooking they have less acceptance. Washing car and cloth, house cleaning, again less acceptance. More acceptance will be given to irrigation. See, the dark color is more here and here. Even in California, if you see, drinking they have a less acceptance. Cloth washing and house washing they have medium acceptance. But for lawn watering and garden watering, high acceptance. Okay. Moving on to the seventh question. Which of the following section of society is likely to have a higher acceptance? So, age-wise, younger people. Education-wise, highly educated or educated people. Religious-wise, non-religion people. So, think about this combination. Who is having higher acceptance? Young people, non-religious people, educated people will have high acceptance to the wastewater recycling and reuse. Okay? Yeah. So, the people with the younger population, men are accepting more. People with a higher level of acceptance are having highly educated. High income people are ready to accept. Non-religious people are ready to accept. Okay. So, based on this, the combination was derived. In the eighth question, which of the following is a right approach to enhance public acceptance of wastewater use? What can I do? I can charge the recycled water supply? No. Provide high-end treatment? No. Based on the intended purpose only, I have to treat, right? Public awareness campaign I can do through media and women participation, because media plays a major role. Women plays a major role in water reuse. Water is mostly related to, because those they are using more, so that is related to them. And acceptance is based on them. The health risk and all, they will assess a lot. So public awareness campaign involving media and women. Others are not enhancing the so regulatory requirement reward I can give, public awareness campaign I can do, inclusion of media and women, knowledge on water cycle, and groundwater abstraction I have to control. Otherwise, they will use only groundwater. If I stop the groundwater supply, then not supply stop. It's like I have to retard them not to using the groundwater. Then, zero liquid discharge. Which agency enforcing ZLD after its regulating compliances for gross polluting industries? What is gross polluting industries in India? The industry having greater than 1 lakh liters of wastewater produced every day. That type of water intensive needs like steel industries, pharma industries, cement industries, not cement, steel, pharma, thermal power plants, they are using lots of water, right, for their production, right? So they need to follow ZLD. So which agency enforced this rule? CPCB in India, because that's the Central Pollution Control Board. So Central Pollution Control Board, they have a guidelines for techno-economic feasibility of implementation of ZLD for water polluting industries. Okay, it's mandated for all glass polluting industries in India. ZLD policy. Okay, 10th question. Singapore's new water is one of the leading example in the world for new water. They have two options. One is uh, non-potable, non-potable, and then indirect potable. What is non-potable? Not for public consumption. So what they will do for irrigation or industrial reuse or air conditioning and all, they will do. What is potable reuse? For consumers. but not directly supplied to the consumers. Indirectly, how they will recharge the groundwater, that it will be taken to the water treatment plant, that it will be consumed by the people. So it's consumed so potable, but indirectly consumed so indirect potable. So new water, Singapore new water is indirect potable reuse. Another one is non-potable reuse. That is for cooling, air conditioning, industrial. Mostly, which industry is using new water more? Wafer fabrication plants. Okay. Now answer the next five questions based on this figure. Okay. So there is a wastewater recycling system. So the recycling system shown in the figure appears to be for municipal, industrial, agricultural, stormwater. Because see the image carefully, they have ultrafiltration. Uh,
Sir, excuse me.
yeah, please.
Sir, your skin is not visible.
Is it not visible
No.
for others? Ponana sir, could you able to see?
No, this is not visible. Your skin is not visible.
Can you? Okay. Now? Okay. Sir, can you rejoin again? It's visible for others. Can you leave and join again? I'll
Okay.
wait. Yeah. Mm. Is it visible now?
Yeah, now it's okay.
Okay, fine. So, I will zoom the picture. They are asking this wastewater treatment and reuse option is for municipal, industrial, stormwater, or agricultural. So, see, from the wastewater treatment plant, it is coming to the ultrafiltration unit. Then from the ultrafiltration, it is supplied to the reverse osmosis, the UF permeate. Then it is also supplied to the vacuum evaporation. The permeate is coming to the RO. RO again purifies it for reuse. Uh, the UF filtered water is directly going for horticulture and gardening. The US reject, ultrafiltration reject is going to the evaporation, and the solids will be taken, concentrated solids will be disposed in the form of crystallization. Again, the distilled water is coming after thermal exposure. Pure water will be coming. Here also pure water will be coming. RO reject is also going to the evaporation unit. Then pure water is again taking to the treated water, it's mixing and then going for water processing. Right? They are asking this type of system will be used for, we won't do this for municipal wastewater, we will not do this for agricultural wastewater, not even for stormwater. This kind of tertiary treatment, solids removal, will be used for industrial wastewater treatment. So the answer is industrial wastewater treatment. Next five questions is based on this image, so please listen carefully. So they are asking the recycled system shown in the figure appears to be for industrial wastewater recycling. Okay. Then sewage, stormwater, or agricultural runoff usually do not require ultrafiltration or RO and evaporators. This system here looks more for industrial application. Now, the question is, which of the following reuse water have received relatively less degree of treatment? Pipe A, pipe B, C, F. Which is having less degree of treatment? C, A. A is here, B is here, C is here, F is here. Okay. They are asking which is having less degree of treatment. First, the wastewater is coming and it is taken to the ultrafiltration. From the ultrafiltration, the permeate is coming, that is going as a C. After going through RO, more purified and it is coming as B. So, comparing B and C, C is less degree of treatment. Okay. Then the UF reject is going to the vacuum filtration and concentrated distilled water is coming. Distilled water is evaporated pure water. That is in F. So, distilled water is comparatively high degree of treatment. So, still C is more less treated. Okay. Then what is A? A is the mixture of distilled water of G and F. Again, this is also distilled water only. So A, B and F are highly treated water. C is less treated. Compared to other, the UF permeate is less treated before RO. You got it? So less treated is 5C water. Used for horticulture and gardening directly. Or else you can put it in the RO and make it more drinkable. Pipe F and A are carrying distilled water. So it is not, it is pure. Pipe B, RO treated water. So that is also not less degree. Pipe C have received comparatively lesser degree of treatment up to ultrafiltration. Comparatively. Even ultrafiltration have good degree of treatment, but compared to other, there is having less degree of treatment. Okay. In the same figure, how is the RO reject being managed? From the UF, the reject is going to the evapotranspiration, vacuum evaporation. RO, the pure water is coming out. The reject RO concentrate is going again to the evaporation plant. So all the salt, high salt content water is coming to the evaporation plant, where the concentrated water will go here, distilled water will come here. Another vacuum evaporation, solids will go here, treated distilled water will come here. So RO reject is also managed in vacuum evaporators. You got it? Not in discharge, not to UF, not directly used in process. It's going to the vacuum evaporator and treated. Got it? RO reject is being treated at the vacuum evaporators. Can I move to the fourth one? Okay. See, RO reject is being treated at a vacuum evaporator. It's shown in the figure. Fourth question. Water recycled for process water is likely to have. Where is the process water? Here. Water all is coming here. After RO, it is coming. After vacuum filtration, the distilled water is coming. After again vacuum evaporation crystallization, distilled water is coming. So this two distilled water are mixing into A. This A is mixing with the RO filtered water. Then all this pure water is coming to process water. So it contains TSS, zero TSS. Yeah, because RO there is no TSS. All TSS will be removed. Distilled water will not contain any suspended solids. Very low TDS or moderate TDS. RO will remove all the dissolved solids also. So TSS will not be there. TDS will also be very low. So moderate illa. Almost zero TSS. TDS will be very low. So answer is A. Okay, because RO treated and distilled water. Pure, very pure. Almost zero TDS, TSS and very low TDS. You got the question? The water recycled for process water is likely to have almost zero TDS, and as the water is coming from evaporation unit, distilled water and RO permeate. RO permeate is pure. Reject is very high concentrated. Okay. Fifth question on the same picture. Role of ultrafiltration. Why we need ultrafiltration here? What it is doing? The wastewater is coming in. It is treating to a degree to give to the RO, because RO it can't directly take the wastewater. It need to be pre-treated. So UF ultrafiltration is a pre-treatment unit for RO, and the UF will give the reject to the evapotranspiration. Right? What is the answer here? Treat water for horticulture. That is not the purpose. Pre-treatment, the water to be fed into the RO unit. That is also correct. Reduce volumetric load on wastewater and vacuum evaporation. Uh, that is also correct. Treat water for horticulture and reuse. All seems correct. Reduce volumetric load on wastewater and vacuum evaporation. Even though it will also give. So is it all the above, or B is exact? Pre-filter for RO. Okay. But it is also giving water to the horticulture, but that is not the aim, right? Okay, they are saying everything. Based on this figure, based on the given system, the treated water is going to the horticulture. It is the feed for RO, and also it is reducing the volumetric. That is correct. Yeah, yeah. Vacuum evaporator, it is reducing the load, because if directly it's going to RO, it will give more reject. Then more water will come to the vacuum evaporation. But if you treat with the ultra pure, somewhat will come, and RO will give you some only less reject. So that is the advantage of US before RO. Okay. Treating water for horticulture and gardening, pre-filter for RO, further as a part of water being used directly after UF, Part going to RO unit, it is also reducing volumetric load on the vacuum evaporator. Okay, 10 more questions we will run up. Which of the following is a major challenge in the wastewater recycling? Which is the major challenge? Potential consumer may not accept. Yeah, that is the problem because they think it will give health risk. Crop production using recycled water may not be find buyers easily. Yeah, as I mentioned, crop from the recycled water, even other country will stop the export or import. So that is the political or burden to the import and export between the countries. The wastewater recycling program may lack the political motivation. That is another major challenge. If the government is supporting, that will work good. So all the above. That is correct. You got it? Yeah. So the major challenges are all this: social acceptance, trade barriers, political constraint. This is the first major challenge. Then, which of the following is not a potential risk associated with the wastewater recycling scheme? The technology available for water recycling are still inadequate. Is it so? And prone to frequent failure. No, the technology is good. Water recycling typically has higher cost than conventional. Yes, because water recycling will have higher cost and higher risk. Okay, but the statement 2 is correct. Not a potential risk associated with the waste. The question is which of the following is not a potential risk associated with the wastewater recycling scheme? This is not a potential risk. So statement 1. This is a risk. Yeah, it is a cost. Cost is a risk, but first one is not making any sense. We have a good technology to treat the water. Yes. So the cost wise, it is higher. See, the financial resources are adequate, but the challenge is the cost. Public acceptance of reclaimed water is most difficult for industrial reuse. Yeah, people will do, no issue. Indirect potable use, yeah, if it is coming from the groundwater but already containing wastewater, treated wastewater, I don't find any problem. Environmental reuse, fine, like gardening and all. But directly, if you are giving for potable use, I will object. So that is a difficulty by the public point of view. So direct potable use. So high level of acceptance for certain use, the potable water has the lowest acceptance. Okay. Central Pollution Control Board in India mandated decentrality for which industries? Grossly polluting industries. What are grossly polluting industries? Those who are generating more than 1 lakh liters of wastewater every day. Yeah. Okay. Decentrality became mandate for the gross polluting industries in India by the CPCB. Okay. Fifth question is, alternate water sources like harvested rainwater are preferred by the people over rejected wastewater, right? Yes, it's correct statement only. People are ready to accept rainwater instead of treated wastewater. Why? Rainwater is more readily available than wastewater globally. Yes, that is correct. Because I can simply take in my home garden itself. The technology involved in the rainwater harvesting is cheaper and readily available. That is also correct. I can simply sediment it and I can drink. No need of much treatment. The concept of harvested rainwater usage is easier to understand for common people. I can say the people just store it in the water, so just collect it in the pit. It is easy to concept is easy to understand by the common people. So preferred, okay. They are saying why it is most preferred. The answer is people prefer harvesting rainwater over recycled water since the concept of harvesting rainwater usage is easier in understanding than treatment procedures for reclaimed. Okay, that is correct. Even though others are also correct, more readily available. Okay, even recycled waters are also readily available in huge quantity. So that is wrong. Then technology involved in the rainwater harvesting is cheaper and readily available. Yeah, that is also correct. This statement is also correct, but first statement is wrong because even recycled water also readily available in huge quantity. Most appropriate is third option. Technology involved in rainwater harvesting is cheaper. Oh, it's not cheaper. Yeah, technology rainwater harvesting is not cheaper. It will take some financial burden to plumbing, choke pit, filtration unit. That is also required. Yeah, but concept is easy to understand by the common people. So the exact answer is option C. Yes. Sixth question. There are two statements regarding fit for purpose wastewater treatment. What is fit for purpose wastewater treatment? We need to treat to the desired level, not over treatment, not under treatment. So fit for purpose is an environmentally sustainable and economically efficient wastewater treatment philosophy. That is correct. Degree of treatment is decided based on the intended end use. Yeah. What I am going to use, that much level I will treat. If I am going to use for drinking, I will treat up to tertiary level. If I am going to use for toilet flushing, primary and secondary is enough of trickline water, and it avoid over treatment and under treatment. So both statements are correct. A is correct. R is the correct explanation of A. Yes? Okay. This is about fit for purpose. So wastewater train is selected based on use of reclaimed water. Avoid over treatment, obviously avoiding under treatment. Okay. Seventh question is the most predominant use of recycled wastewater across the globe is where I can use people will accept mostly for potable or no. Industrial reuse, no. Unrestricted domestic use, illa. Reuse in irrigation, everybody will accept. Okay. It's the most predominant way of using globally. People are doing. Yes. See, globally, most of the people all over the world less opposed for use in irrigation and limited contact uses. Okay. Identify the correct statement concerning the socio-democratic factor, age, gender, education, religion, and all. Okay, affecting the public acceptance. Women are more accepting the recycled water than men. That is wrong. The level of income does not particularly impact the acceptable. No. High income people are accepting more. Younger population is more accepting than the of recycled. Yeah, that is correct. Compared to old people, younger population is accepting more. The recycled sewage has more social acceptance than recycled grey water. No. Sewage is having less acceptance. Grey water is having more acceptance. Okay. Yes. Then regarding psychological factor, the trust of the people in the wastewater management authority, the overall concern of the general public, the scientific department is correct, trust is correct, overall concern on the environmental sustainability is the last point, that is also correct. So all the above are the psychological factors. See, trust, health risk, environmental concern, fairness in supply, science and technology, belief on science and technology, that is the belief, trust. So all these are psychological factors for the wastewater reuse and recycling. Which of the following recent research trend considers wastewater as an alternate water resource? Research trend they are asking. Integrated urban water treatment, energy production from wastewater, automation in wastewater to biosolid management. Which of the following recent research trends considered wastewater as an alternate water resource? So as I mentioned, resource, what are the resource? Stormwater is on resource, rainwater is on resource, recycled water, wastewater is on resource. Along with the groundwater and surface water, we need to integrate. That system is called integrated urban water management. That's what research as an alternate resource, along with the stormwater and rainwater and the groundwater and the surface water bodies. Okay. 11th question. Decision support system in wastewater management are usually guided by, as I mentioned, energy, cost, life cycle cost, um, what else? Impact on the environment, health risk, all data need to be collected for different alternate treatment technology and fed to a fuzzy logic system. That fuzzy logic will provide you a score, final score. This is the whole framework for decision support system. So this analysis is called multi-criteria decision analysis. So that is the major driving force or guiding force. Multi-criteria decision analysis. All this criteria I am giving. So multi-criteria decision it's giving, right? Carbon emission, that is major one. Okay. Which of the following could be a prime driving factor triggering the adoption of wastewater reuse to tackle the water storage and supply demand gap, to circumvent the rigorous and costly requirement of nutrient removal from wastewater effluent, setting off regulatory requirement enforcing wastewater reuse. Which factor is prime driving factor? Water shortage and supply demand gap. Yeah, if more demand is there, more wastewater they will reuse. So that is one driving factor. Is it a major driving factor? To circumvent the rigorous and costly requirement of nutrient removal from the wastewater effluent. To circumvent the rigorous and costly requirement of nutrient removal from wastewater effluent. Setting of regulatory requirement enforcing wastewater use. Okay, that is also a driving force, but that is a primary driving force. I think A and C both seems correct. Which seems correct? A, B, C, or D? Prime driving force. To circumvent the rigorous and costly requirement of nutrient removal from wastewater. Let me see the answer. All the above. Yeah. So why the third point is correct? See, adopting urban water reuse ranging from these things. So demand in arid and semi-arid region, that is a major alternative. Last point, see, several water reuse programs have also been initiated in response to rigorous and costly requirement of nutrient removal from the effluent. That is one of the driving factor for the wastewater reuse programs around the world. One, new water in Singapore, which are the statement is incorrect. Despite strong opposition from the government, no. New water has a strong government participation. There is no opposition. Government is involved in the new project, so that is incorrect. New water is used for both non-potable as well as indirect potable. What is non-potable? For industries and air conditioning. The indirect potable is for consumer, but not direct. It's supplying to the groundwater recharge. So both non-potable and indirect potable use. Then engaging the media that helped in new water. Technology demonstration and information sharing increases the stakeholder participation. So these three are correct regarding new water in Singapore, but government opposition is wrong. See, strong support from the government is the first critical factor in the success of new water in Singapore. Yes, and it is also considered as non-potable and indirect potable use. Okay. So what about the 14th question? Match the following regarding wastewater recycling and practice in different region. What they did in Florida, California, and Israel. Who used it for irrigation? Who used it for indirect potable use? Who used it for industrial application and aquifer recharge? I think 1, 2, 3. Because Israel, they use it for agricultural irrigation, even for edible crops. California, they use it for indirect potable reuse, like recharging the groundwater. 1, 2, 3 is B, right? Florida, they have used it for industrial application. Yes, this is correct. And aquifer recharging. Yes. See, California, indirect potable use. Indirect potable use, they are supplying to the groundwater after microfiltration, reverse osmosis, and UV. Florida, they did for um, toilet flushing and all different industrial applications. Israel, they are using the agricultural and irrigation facilities. Okay, the last question. A possible application of decision support system in wastewater management system could be possible application. We are applying the DSS for 4 things. First is selection and design of treatment process, which among the alternatives, which is good. Selection, it is useful. Monitoring and control of treatment plant, it is useful. Identifying reuse or reuse options as well, it is useful. So all the above. Right? See, Listing of possible alternatives, evaluating the alternative, identifying and choosing, assessment of possible impact. Also, it is the DSS is helpful in all the systems. So this is D is correct. Got it? So I think we came to the end of this NPTEL course wastewater treatment and recycling. I have scheduled one more additional class on next Monday, 6 to 8 p.m. I think if any change is there, NPTEL team will intimate you through the mail to all the participants. If you want to revise all the topic in 1 hour and do the this 12-week assignment what we have done in 2025, I will show the answer key and I will discuss the problems that will be helpful for your exams. So those who registered for the exam, please join for the additional extra class. Okay, on next Monday, possibly 6 to 8. Okay, so thanks for joining. If you have any doubt about the course and if you want to do any personally want to talk about any research topics, you can contact me anytime. And thank you for joining and thank you for your interest in this course. Do well for your examination and don't forget to give the last week assignment before Wednesday. Thank you all. Thanks for joining. Yeah, thank you. Hope you enjoyed my session. If you have any feedback also, you can unmute and you can ask, or you can text me also anytime.
Yeah, thank you, sir. It was
Sir,
cool.
Yeah, please.
Yeah, it was
sir,
very
we will submit.
Hello.
Sir, I think you say that suggestion in fourth unit,
Yeah, please.
fourth unit. Sir, I think you said that in previous week, fourth unit problematic concept you're going to come up with next year, upcoming weeks, sir.
Yeah, please.
Yeah, I think you will come up with 9 important questions from the fourth week of the week
Oh, you're
of
asking about
problem.
important question. I don't know about the question. Actually, I am also going to write the exam. I'm just a problem solving teaching assistant. So I don't know about the topics also, but you can focus on the quality, that quality of wastewater like pH, EC, TDS, BOD, and if you are struggling with the problems, don't concentrate much on the problem side. But it is also very easy. You can ask in the last session. I can solve with you anytime, no issue. But theory part and mostly what the assignment we have discussed itself enough for your exam preparation. Don't worry much. You can score more than 80% easily. It's a theoretical side.
Thanks for your suggestion.
Yeah. Thank you. So if you don't have any question, you can leave the meet or you can unmute and you can ask. Yeah. Thanks for joining. I'll close the meet. Thank you all. We'll meet next week.